Hello, and welcome to Civil Engineering Tech Program's pre-recorded prep lectures. This one dealing with structural mechanics, determining the resultant using the table or the numerical method. Let's take a look at this. If we have a force, a body, with some forces acting on it, let's say we have a force here of 400 pounds acting at 220 degrees. And we have another force acting on this body of 200 pounds acting at 300 degrees. And we have a third force acting on this body of 50 pounds at 20 degrees. How do we determine the resultant numerically? We have seen through the graphical tip-to-tail method how to calculate this graphically. The question is, how do you calculate this numerically? What I'm going to introduce is something we refer to as the table method. It's a way to allow yourself to organize your thoughts and allow the equations to do the calculations for you if you set it up correctly. And the main thing you want to make sure on is that 0 to 360 use the standard Cartesian coordinate system for your angles. So each one has a standard Cartesian coordinate system. In this case, they're all laid out for us. This is at 20 degrees. The 400 is at 220 degrees. And the 200 is actually indeed at 300 degrees. So, how do we do it? Well, we have the table. So, this would be ID, magnitude, and theta. And then you just fill them in. Let's go back and look at them. So, we have, we'll call this P1, we'll call this P2, and we'll call this P3. So P1 is 50 at 20 degrees. So P1, magnitude of 50 pounds at 20 degrees. P2, 200 pounds at 300 degrees. P2 is 200 pounds at 300 degrees. And P3 is 400 pounds at 220. 400 pounds at 220 degrees. And the idea is that you set yourself up, and it's a nice, orderly manner. Once you set the table up, you allow the table to calculate, but the idea is to set this up correctly, because if this gets set up correctly, everything else will wash out on its own, and it'll work. Once this is all your data, so this is your data fields, then you have your components. Fx and Fy. Fx, the equation for Fx is the magnitude times the cosine of theta. Fy is the magnitude times the sine of theta. And so, for P1, 50 times 20 cosine gives me a value of 47.0 pounds. 200 times 300 cosine gives me 100 pounds. And 400 times 220 cosine equals, so 400 times 220 cosine equals, and you notice that you allow the negatives to remain, 306.4 pounds. Fy. So I take 50 times 20 sine equals, and this is 17.1 pounds. 200 times 300 sine equals negative 173.2 pounds, and 400 times 220 sine equals negative 257.1 pounds. When you sum these forces up, sum of forces in the x equals the resultant in the x, and sum of forces in the y will equal your resultant in the y. So we add them up, and so 47 plus 100 plus 306.4 negative gives us our x is negative 159.4 pounds. Our y is equal to 17.1 plus 257. Oops. 17.1 plus 173.2 negative plus 257.1 negative. Oops. 17.1 plus 173.2 negative plus 257.1 negative equals negative 413.2 pounds. So we have a 159, 214. So then we know that r is going to equal the square root of rx squared plus ry squared. And so if we do that, 159.4 squared plus 413.2 squared equals second function square root. So we're talking a magnitude of 442.9 pounds. And my phi is going to be what? They're both negative, so we know we're in the third quadrant. So if I say phi is equal to the we'll say the cosine, I can pick any of them, of fx over f. Actually, let's do the tangent, because that way we don't use any reciprocal numbers. So if we say phi is equal to the inverse tangent of fy over fx, so fy is 413.2 divided by 159.4 equals second function tangent, and that tells me it's 68.9 degrees. But from before, we saw when we take the inverse tangent, we have two potential solutions. So we can have this solution or this solution for phi or phi. And so we know this is 68.9 degrees, and since we know the cosine, the fx and fy are both negative, it's this angle that we're looking for. So we add 180 to that, and we find out that phi is going to be equal to 248.9 degrees. So we have a magnitude of 442.9. Let's do this real quick. So if we take all this, So we have those three forces. And so we have this force plus this force plus that force. Now obviously they're not drawn in the correct orientation or anything, but we have some rough idea if we'd actually physically draw these at the correct orientation. And checking our numbers, make sure we didn't screw up the numbers. So 200 times and 200 times 300 cosine. Okay. So, these look like good numbers. So if we had the effect of 50 pounds times 20 degrees, 200 pounds times 300 degrees, and 400 pounds times 220 degrees, the end result is going to be coming down significantly in the y and not much in the x. So relatively. So it is going to be, if we look at it, we would expect a resultant of 442.9 pounds, 442.9 pounds, and an angle of 248.9 degrees. So that would be the resultant. Let's do one more example, and that we'll pull one from the book. Let's say we have, for this vector addition, we have a member sitting here, and we have, from this point, we have 30 pounds of force pulling this way. We have 15 pounds pulling this way. 15 pounds pulling up at 30 degrees. We have 40 pounds pulling up at an angle of, this is 45 degrees. This is figure 2.5 in the book, page 29. And then we have 10 pounds of force acting at 60 degrees. And finally, this is back to 45. And we'll call these members A, B, C, D, and E. So therefore, if we ID with a magnitude and a direction, so A, B, C, D, and E, A has a magnitude of 30 pounds, angle of 0. B has a magnitude of 15 pounds, angle of 30. C has a magnitude of 40 pounds, an angle of 75 degrees. D has an angle of 10 pounds, an angle of 135 degrees. And E has a magnitude of 15 pounds, and its vector is shooting at 180 degrees. So there's our ID. Then we can calculate the Fx and the Fy of our components. So Fx, we know it's f cosine phi. So 30 times 0 cosine gives me 30. 15 times 30 cosine gives me 13. 40 times 75 cosine gives me 10.3, 10.4. And then 10 times 135 cosine gives me negative 7.1. Actually, while you're doing these, take the fx and fy to 2 decimal places. So 40 times 75 cosine gives me 10.35. And 10 times 135 cosine gives me 7.07, negative 7.07. And then 15 times 180 cosine gives me negative 15. For a total of 30 plus 13, 30 plus 13 plus 10.35 plus 7.07 negative plus 15 negative equals 31.3 pounds in the x. In the y, 30 times 0 sine equals 0. 15 times 30 sine equals 7.5. 40 times 75 sine equals 38.64. 10 times 135 sine equals 7.07. And 15 times 180 sine equals 0. 7.5 plus 38.64 plus 7.07 gives me 53.2 pounds. And so then we have our resultant. Our resultant is going to equal the square root of fx squared plus fy squared, which is equal to 31.2 squared, 31.3 squared plus 53.2 squared equals, square root of that is going to be a magnitude of 61.7 pounds, and my phi is going to be the tangent -1 of fy divided by fx. So that's going to equal the tan -1 of fy, 53.2 divided by 31.3 of 1.7 basically. And do a second function inverse tangent, and I find out my phi is equal to 59.5 degrees. So therefore, I know off of that my resultant is going to be at 61.7 at an angle of 59.5 degrees. And thus this solves your tabular graphical method for determining the resultant. Thank you.